It. Go ahead and so your question was if your homework isn't submitted because you're having problems with AWS, is that okay? And the answer is yes. And the reason for that is A, I have a grace period. B, I'm not going to be super picky about the due dates as long as it doesn't become a problem with people procrastinating. So if I start seeing everybody's not turning in their homework and they're falling behind, then I'll start charging the penalties on the homework assignments. But I want to give people the ability to not have the stress of turning things in. So but if I say everything's due at the end, then everybody complains at the end that it was due at the end and I should have had to do throughout the course. So um, but your question, you're on homework 3, so you're working on that, which is you're working a little ahead. That's okay because you're still waiting on the AWS part. I'm going to go through homework 2. Uh, if we have time, we can maybe go through homework 3 as well. But that one's a little bit more involved. I may not have everything set up on my computer for that one. Okay, so for homework 2, the first section is all about just getting your SSH set up, being able to connect through SSH, and just running some basic commands to learn where you're at, who you're logged in as, what host you're on. That's really the gist of part 1. So those are just very basic things. I'll run through them real quick and explain each of them just so you understand the context for each one. So for part 1 of homework 2, PWD tells you where you're located. It stands for Print Working Directory. When you do who am I, this tells me who I'm logged in as. When I do a uname, sorry, I did the wrong one. Uname minus n tells us which host name and what domain I'm on. If my computer was in a domain, it would say like john.com or something like that. The uname minus a version not only gives me the host name at the beginning here, where it says this here, it tells me I'm on a Darwin kernel, which is a Mac. Okay. Tells me version information, tells me the date, and I don't even know what this bit is. But it's just telling me all information about the host that I'm on. The next thing was who. So this tells me who's logged into my system. And then let me show a couple things here. Number 1 is console. So the console is the actual physical machine. So if right now I'm on my laptop, I'm connected via my machine, I'm on the console. Okay. I also have this teletype server here. That's what this stands for. Okay. And I've got that. That's this one that I'm on right here. I just opened it. So I've got a terminal window on my console, and then I've also got a remote session on this machine. Okay, so I can see that. If I do the W command, which is the next piece of the process here, it's optional. It shows me some other information. It shows me the same information as who's on, when did they log in, et cetera. And are they logged in locally or are they logged in through like SSH? Okay. But it also shows me the current time on my machine, how long my machine has been up. So I bet you never see this on a Windows machine, up 19 days, right? That was a joke. There's 2 people on here, and then this shows me the load average of my system. Okay? And that's just how busy my system is in terms of processing and whatnot. That's just all we need to do for part 1. It's just the basics of logging into the host and just taking a look around. With part 2, again, if you have a question about this and want me to stop, let me know. But part 2, the next thing is we're going into navigating the file system here and doing file management on the Linux host. And so there was a question earlier about the $ versus the pound sign. So the $ means I'm an unprivileged user. And this is what my prompt is set up to show me here. Okay? It's going to show me my host name, and then that I'm in my home directory, that's what the tilde is, and then my username, and then the $ prompt. This is configurable. In the Microsoft Teams, I just posted a URL. If you want to make this customized, it's just like customizing anything else on your computer. You can get really fancy. You can make it color-coded. You can have it, have the full path. You can get pretty crazy with it. I like to keep it simple, okay? And the reason I keep it simple is if I make it really long, then I have less room to type on that line. Okay? If I was root, so if I did something like this to become root, hold on, I've got to remember my password. Now I'm root, you can see I have a £. And that's a visual reminder that I'm logged in as root. That's a bad thing. I don't want to do that. As we go through part 2, we start off by doing a directory. So we can create a directory. In this case, we're going to create one called JDO. And if I did an ls, I'd see that there is a JDO somewhere here, right here. And also list it that way. You can see it's just a directory, nothing in it. The next thing is I want to switch to that directory. So I change directory or CD into JDO. And now I'm in this directory called JDO that I've created. Now what we're going to do here is I'm having you do a simple for loop. Okay? You could consider it, I guess, your first bash or shell script, depending on what shell you're running. And all we're doing is a for loop. So we're saying for num, num is the name of a variable. So we're saying for num or number in, and then we're using the sequence command. And what the sequence does is it's going from 1 to 99. Okay? And let me show you what happens if I do that command without a for loop. If I just do seek 199, I just get numbers printed out 1 through 99 here. I could get the same thing if I went here and did this, echo 1, 2, 3, 4, 5, etc. Okay? But I have to type a lot of things. I can also do things like this, sequence 199, and I can echo out that sequence of 1 to 99. This is just very basic shell scripting. I wouldn't even call it, it's not really true programming, but it's programming light, I guess is a good way of considering it, pretty simple stuff. A for loop allows us to run a command against the output from another command. In this case, we want to basically create 99 files, but we don't want to have to go and type in 99 file names and the touch command for each one. Okay, so what we're doing is, I'm going to do it with letters for this thing, is touch.text, a.text, b.text, whatever. And if we do that, we created 3 files. Now I'd have to do that 99 times. That would take me a very long time to do. And so I told you in the first class that it's all about being efficient, aka lazy. Okay, so we don't want to have to manually create 99 files. So I can create 99 numbered files using a for loop like this. So it's taking a number as input right there from the sequence command. And then it's going to go for each one of those numbers. I want it to do something. So I say do. What do I want it to do? I want it to touch a file, and I want the file to be called file. And then I'm giving it this variable num.text. And the way, I'll explain this in just a second. There's multiple ways to do this sort of thing. I did it the first way. Okay? And the first way gives me file 1 through 99.text. Okay? It was a lot faster, right? As long as we don't have people talking over each other, I'll let you all be unmuted. So, okay, as long as we can keep it peaceful. Should be able to unmute yourselves if needed. All right, so we created 99 files and we did it in 4 simple lines. But I didn't explain what this $, curly brace, num, curly brace meant. Num is a variable. We specified it here. We said num is equal to the value of the output of the sequence command 1 through 99. So it's going to go through a loop, and it's basically going to say num equals 1, touch file 1.txt, num equals 2, touch file 2.txt, and so on and so forth. Now we can write this very similarly, the same for loop, a little differently. I'm doing it the way I do it because that's how I was taught, and some shells are finicky. So I ought to be able to do this exact same thing here, where I just do this instead. And I'm going to call it num dash a.txt. So now I should also have files with this dash a. And the only thing different is I did a dash a so I could differentiate, and I got rid of the curly braces. It doesn't matter. I was just trying to teach you the way I learned. But if you want to save 2 keystrokes for your variables, you can. Just be aware that there might be issues with certain characters if you don't use the curly braces. So you might run into issues of characters or certain shells. It may not work properly. If it doesn't work, you'll get an error message and it won't be as expected. Now, this class is not about programming, but I wanted you to see that you can, if you need to go create a bunch of files, this is the simplest way to do it. You just create a loop. We could just as easily, do this with a B instead, we could just as easily go back and change this to 500. Okay. Takes a little longer, but when we're done here, we now have a lot more files, if it worked. Yeah, there we go, see? So if I count the files in this directory, I can see we started with 0 files about 5 minutes ago. We now have 704 files that were created programmatically. Okay. Do any of you want to go and manually create that many files? No. So I want to show you very simple. Anything you need to do with a shell script, you ought to be able to find an existing shell script that does at least 75, 80% of what you want to do out on the internet already. Stack Overflow is a great place to post if you're trying to do something and you're not sure how to do it. That's a great place to post if you need a shell script to do something. Okay. And then most of the time, someone will be helpful and post an example for you. So all this did was create a bunch of files in this directory. So I can use the ls command and I can see all the files. I can do only the non-hidden files. I can also do in this format where I'm not listing it in a long listing format. I'm listing it in a columnar format. Right? Now, when we combine commands, we can pipe commands together. So some of you have maybe already practiced this. So when we use this pipe symbol, and on a PC, it's a up and down line with a space in between it. Okay. On a Mac keyboard, it's going to just be one line, solid. But when we pipe things together, we're taking the output from the first command and we're sending it to the second command. So this allows us to get really complex in what we can do. We can chain as many commands together as we want. So I can ls-al, I can pipe it to grep. Grep is a search tool, and I can say, I don't want to see any, I stands for ignore. So I want to ignore anything with a -b, and I want to count that. Oops, what did I do here? Let's do that. So if I ignore all the files with a B in the name, the b.txt, I only have 501 files. Okay. So I'm piping the ls command, and I'm sending the output to the grep command. The grep command in this case is excluding files of b.txt, and it's sending the output of that command to the word count command. And it's telling me there are 501 results here. Now, if I only want to see the b.txt, I do this. and there's 500 that have b.text in them. Okay. All right.
Hey, Professor, I actually have a quick question here. What is the difference between using the grep command and doing -I versus using the grep command and doing -v? Because I know or later in the homework you have us do an example with
Yeah.
regards to that.
So grep without the I is searching for this text. Grep with the -I means ignore, and it's going to ignore whatever text here. Now you can chain multiple together. Let me show you. So you can chain, you can say, show me everything with an A. Is that a good idea? Let me see here. Show me everything with text, and then ignore everything with a B. And then tell me the count. Okay. So I can chain as many of these together. So I can first search for text, and then I can ignore certain text. Or I can ignore first, and then search for another string afterwards. So this is how I can, eventually you can get to the point where you can find specific text inside files using grep without even opening the file. So you can do like a find on all the files in a directory, send the output to grep and have it, hold on, my dog, I gotta get rid of this dog. She's going crazy. Get out of here, come on. I can search for text without ever opening a file. So let's say let's say there's actual data in all these files. There isn't, but let's just assume there's data. I want to know which files have a search string in it. Then I can do like an ls grep for text in the files. I can do a find on the files, grep for the text, and then I can output the file names with the text in them. So if you are interested in this, I recommend that there's some great books on the Bash shell and other shells from O'Reilly that you get for free as students through the library, through the Safari Books Online. So that's a great resource to really start playing with this. But you can just play around. I'm going to pause the lectures, as I said in my announcement earlier for this week. I'll release them later in the week. That way everybody gets a chance to catch up. Okay. So what this will mean is you can go and explore, and I want you to explore. So don't just limit yourself to what you have to do for the homework. You should be using this time to really play around with the command line and get familiar with it. Because we're going to start doing things on the command line, and I'm going to give you some guidance, but it's going to be better for you to have some experience with the command line. Okay, so do some free exploring on your own. Going on to the next part of this particular activity, Monty, do you have a question?
Yes, going on that note.
Yeah.
So I started taking a lot of the material, which is why I got a bit ahead, outside the class and implementing it into a project that me and my friend are working on. I don't know if that's necessarily a good idea. You said go explore. I remember you saying that in previous classes, but what we're doing is we're implementing a database and then using Python to scrape information off of like Yahoo Finance. Would that even be like, is that too tangential for the perspective of this course?
I don't think there's a problem with you exploring things like that. I just think you need to, I guess, divorce that from the class itself. That's an activity you can learn, and I think that's great for you to do. Just that I'm probably not going to be able to help with specific things related to if you get too far ahead, because it's going to be difficult for other folks to follow what you're talking about. So I think you should definitely explore. You've run Linux before, definitely explore. Don't let me hold you back. But just know that some of the material for this class is going to be gated in terms of coming out, because I want to make sure at least most people are at the same point, so you can help each other when you get to the project. And if everybody, if a few people get all the way to the end of the course in week 4, then what are they going to do for the next 12 weeks? They still need to show up because of attendance reasons, like the discussions and stuff. So but yeah, you're certainly welcome to continue on and explore. And I would expect many of you are going to be in a position where you can probably interview for a job by the time the class is done and have some pretty good skills under your belt. Going on to the next thing is listing files. So what we're doing here is we're doing a listing of files, but instead of outputting it on my screen, it actually sends it to a file. So that what do you call it? I always get these mixed up, but I think that's the greater than symbol. Okay. So when it's that direction, it's output. It's outputting to list files. And Jason asked a question a few weeks ago, what about the .text? You don't need that. The only reason you might want that is if you want to move the file back to Windows or Mac so it's easier for you to open, okay? Because there are helper applications on your regular computer that know that a .text file gets opened by Notepad or text editor or whatever, okay? If you don't need to transfer files back and forth, Unix doesn't use those. The 3-letter extension of the file is a DOS thing, and so people just got used to using it. But it's a DOS it's kind of a DOS thing that happened because DOS was limited to 8 characters and then 3 for the extension. Okay, so well, earlier I used it in my example, but it's not necessary. Okay, so now I've taken the LS and it didn't print how many files on the screen. It didn't print a list of the files. It output it to what's called list files. Okay, so if I look at this list files here, I now have a listing of all the files in my directory, and it's in this file. I look at list files here, I can see that list files is now 47,307 bytes in length, as opposed to these other files where there's nothing in them, there's 0 bytes in them. So another way to think about that is this file, list files, has 47,307 characters. That's another way to look at it, right? Concatenate. I know that confused some folks. So concatenate is a funny name, and its abbreviation is CAT. I don't even know where the word concatenate came from. Okay? I have no idea. But if you're interested in trivia, you can go research who came up with that name. But when we cat a file, we're just looking at it. If you're not a cat person, later on in this example, I think I give you an example of how to create an alias. So you could create an alias dog if you're a cat person. Okay? If you're used to the dir command on Windows, you could create a alias called dir that points to the ls command. But if I do cat, I can look at a file. There's nothing in that file. But if I look at this one here, oops, I can see it has a list of all the files in it. So if I want to look at a file, and let's say this list files, I can also pipe that to like the grep. Okay? So I can say grep -I. I don't care about the list files. I want to count. Hold on a second. Checking something here. Oh my gosh. Been a long day. This should be -V to exclude files, not I. My apologies for that. Okay. So in this case, I'm excluding with the -V, I'm excluding the file that's list files. I don't remember what the so -I.
I'm sorry, Professor. That's the difference between -V and -I. -I is ignoring, and -V means excluding.
No, I made a mistake earlier. This is why I need to check things before I see them when I'm tired. grep minus I is ignore case. So if I were doing, I don't have any capital letters, but if I had files with capital and lowercase letters, I'd use a minus I to ignore the case. Okay. So in that case, it wouldn't make a distinction between capital letters and lowercase when I do a grep against it. Okay. If I am using -v, I'm basically saying it's weird, the naming of it. It's basically invert match. So instead of matching what I state here, don't match it. So select the non-matching aspect. Your best bet is to just look at the man page for grep because it tells all the different options you can pass to it. And that's what I mean by exploration. You should explore all the different options for these commands. Because you can do some pretty cool stuff if you explore it. Oof. All right, so looking at the files here, I can do a file loop here. So I can say for file in ls text. I want to take these files and I want to rename them all. Okay. So what I can do with all these files with .text is I can rename them by using the mv command. And so, for example, I can do mv file, and I can change the file name to new file. And so now all these files are renamed. So if I need to rename a file, this is much faster than me, if I've got multiple files. This is much faster than me going through and manually renaming one by one, which maybe you laugh at me, but my first job, I did that sort of thing. And people wondered why it took me all day to do something, okay? Because I didn't know. I didn't know better. I just assumed that you had to rename them manually. This might be a situation, say you've got a log file, a bunch of log files or something, a bunch of data files, and you've got to rename them all. You might use this type of situation for that. Okay. Now, the last two things in this section are how do I change to my home directory? I can use cd tilde and it takes me back to my home directory. And then the last part is I just want you to be aware of other file systems. So Etsy is a file system where we store things like configuration files. Okay? So if we look at what's in Etsy, we can see there are configuration files. Sometimes they're named with the .conf, sometimes they're not. Okay, this is a configuration file just as much as this is a configuration file. Now we want to see how many files are there. So we can do cd Etsy, and then we can run multiple commands on the same line with a semicolon. So now if I just want to run a bunch of commands, and you might say, why would you want to do this? I just did this earlier today. I've been working, unfortunately I have to pause this part too. Now in environments that don't have those types of security restrictions, you can actually use a variety of different tools to allow you to run a command across a bunch of different hosts simultaneously. And so you can simultaneously be SSH into 100 hosts, 1,000 hosts, however many hosts you want to be logged into, run one command in a window and have it automatically run in all the windows. So there's some ways you can do that. There's this thing called cluster SSH. It's kind of dangerous, but it allows you to run one command across 1,000 hosts or 1,000,000 hosts, however many hosts you want to log into simultaneously. Later on in the course here in a few weeks, we're going to start talking about automation. And the automation tool does that sort of thing without SSH. It's a much more secure way because we can not only run something, but we can plan it ahead of time, test it as a dry run to see what damage it can do before we run it, and we can also revert the change. So if we decide we don't like the change it made, we have the ability to back out the change. And so that's one of the core things we're going to spend a lot of time in this class on is automation that allows us to do that sort of thing. The tool that we will be using is called Terraform, and it's an open source tool with an enterprise version. There are other tools that you can use. They're not as great necessarily for a cloud-based environment, but if you have an on-premise environment, you could use them. You could use them with cloud as well, but they are not cloud-native tools. So we've used them in the past in this class: Chef, Puppet, SaltStack, Ansible, CF Engine. These are all tools that you might see in your workplace. But based on student feedback, I did not cover those this time. They're pretty complicated, and it was a lot of frustration for students last semester trying to use those tools. Right? So we go on to the next step of this process in part 2, which is also the last step of part 2. And we run this command. And this tells us we have 121 files and directories in the etc. Okay? Then we move on to part 3, which is file editing. And did anybody have problems with that, or was everybody good on that? I'm going to show it anyways. But.
I actually found it very cool. I didn't personally have any problems with it. I now know how to actually type things in and create new lines. It's a very cool thing to use.
Mm-hmm. So some of you may use Vim or BI, and some of you may use Nano. I'm sure there are other text-based editors out there. I don't know what they are. What I don't want anybody doing is relying too much on graphical editors on your machine unless you're comfortable getting files back and forth. But even so, that's just going to cause you a lot of grief later on. So I would be very cautious about not using a text editor that's on the command line. It's a good skill to learn. I will be showing you how to use version control here later in the course. And when you get to version control, you can use an editor on your machine, save the file, it saves it to the repository. You can commit your local changes to your repository, and then go onto your server that you create and check out your changes from the repository, which gives you version control on your files as well. So when we get to that point and you start using GitHub, I don't care so much if you use the command line anymore. Okay? But up until we get to that point, it's going to be a lot easier for you if you just use the command line. Now, I also sent out an announcement. You can use AWS or GCP for this homework and subsequent homeworks. I don't care which one you use. I will provide the instructions for both going forward, unless it's a specific lab where it only is available in one of those systems. And in that case, I will try to find an alternative if you absolutely cannot use GCP or AWS. I think most people had problems with AWS. Everything that I plan to use works in GCP. So in this case, we're going to create a file in my home directory. Okay? So I'm just going to call it homework 2. And we just go in and create this file. I'm not going to type the whole thing. So I've got this file. I've saved the file. I've exited the file, but to save it, just do :w exclamation on BI. Nano instructions are on the web page. So now I can search for text in BI and I can replace it pretty easily. There's a BI handbook on the library through O'Reilly that you can read if you're interested. I view it more of a reference though. So if you don't know how to do something in BI, you grab the book and you look in the book. Okay? But I'm just gonna hit the escape key, and then I'm gonna do the $%S. I'm gonna find text and explain what each of these do, called lied. Lied. And replace it with void and G. So what does this mean? The colon, first the escape, and then the colon brings me into my mode where I can actually make changes to the file. Okay. The $& and S stands for search. Okay? The first slash is basically saying search, and then slash is telling me what's the first thing I want to search for. I want to search for lied, okay? I want to replace lied, so the second slash says replace lied with oid. The next slash says I'm going to give it some sort of control character. Tell it something else I want it to do, okay? And that's the G, that stands for global. So what it's saying is replace lied with oid globally throughout this file. So replace all instances. If I don't put the G on the end, it will only replace the first lied it finds called Clyde, okay? So if I omit that G, let me show you, it only replaced the first one. By the way, if I hit escape U, it does undo, okay? Now, I'm going to go ahead and replace it everywhere, though. Okay, so I'm going to replace lied with oid, and now it's replaced it everywhere. Oops, that was supposed to have been Floyd. There we go. And I think we had a question. Okay, so when I create a file with VI, or VIM, it's the same thing for both. VIM just stands for VI improved. I just type VI on whatever file name I want to create. So if I want to create a new one called homework 3, I do that. I just hit enter after that. If I've already created the file, I just type it in and hit enter. And then how did I save the file? I hit escape, :W, and then exclamation point doesn't warn me about saving the file. If I just do W and I made changes or something, then it would basically warn me before I save the file. Yeah, so I just covered that. So escape, the sequence is escape, and then whatever command you want to run. So save, escape, Q to quit. And if I don't want it to warn me before I quit, I do an exclamation point. If I do this, oh, I have no changes for that. Now I have a change. If I do a Q, oh yeah, there's the warning right there. Okay, I can discard my change right there. Okay, so if I open this back up, that space I put in isn't there. Okay, let's see if I caught up on that. How did I replace the letters in the text? Good question. So I hit escape because that's how I change modes with VI. I use a : because I'm going to issue a command. Okay. And the command I'm going to issue is I want to search. So I do %S, lowercase s. I do a slash, and then I want to tell it what kind of text to search for. In this case, I'm going to search for Lloyd. Okay. What do I want to replace Lloyd with? I want to replace it with lied. And I want to replace it globally throughout the file. So now it's replaced it. And now I can save it by hitting escape, :W, exclamation point. And now I've saved this new file. When I'm ready, I can quit by using escape, Q, what did I do? Okay. All right. I've put a few examples of which you can replace in the instructions. But the whole book about VIM is out on Safari Books Online for the library. Nano, there's instructions here on how to do that. I'm not a Nano user, but there are some basic instructions. It might be more intuitive for some of you. Some people it might be more complicated, so you're just gonna have to pick what works best for your learning style. Now on to part 4. So part 4 is all about process management. So processes are like the applications run. Okay? So I can do top, and top shows me all the processes running on my Mac here. You see something very similar on Linux. Okay, we can see that I have 502 total processes, 4 running. Now there's 11 running, now there's 4 running. Many of them are sleeping. Okay. I can see the load average of my machine. I can see my CPU usage. I can see things like memory, okay? And I can see virtual memory or swap files. I can also see the packets coming in and out of my machine. Okay. So you can see since the last time I rebooted my machine, I have downloaded 76 gigs of network traffic, and I've sent out over 1 terabyte of traffic. And you can also see disk usage, right? And then we can also see our different commands, the programs that are running. We can see how much memory they're using. We can see their CPU usage and the amount of time that they've been running. And then the last thing we can see here is PID. That's our process ID. So if we have a process that's running away, even though this is a Mac, I can kill processes. If I can't kill them through my activity monitor on my Mac, I can go in here to the command line and kill things sometimes. Same thing with Linux. You're going to see a process ID and you can kill it. If it's a process that has a child process, okay, so example here, this is the parent process 19705. So if I go over here, and I don't see 19705. Okay, 19545 is a parent process for Zoom. Okay, there's another process over here that occasionally pops up inside of Zoom. That's a child process. If we kill the parent process, we kill all the child processes. If we kill the child process, we only kill the child process, not the parent process. Okay. So we can use kill to kill processes, and I didn't go into this because it wasn't necessary for the primer of command line basics. But if I say look for the Zoom process, okay, I don't want to kill it, but I could kill. Say this process was hung, I could use a kill. And I can send it a signal, and -9 is a signal to just kill it. Okay. And I could say, I want to kill the parent process, which is 19545, and that would kill all of these Zoom processes. If I only wanted to kill this one because it was hung or something, I could kill this particular process. Now, if I did that, it wouldn't actually work because I don't have permissions to kill this running application. I have to be a privileged user like root. Okay. So I could do sudo kill -9 on this process and hit enter, and it would kill the process, but you would all disappear. You can do the same thing on your Linux machine. So if you have a process that's hung, you can kill it. So some of you asked me about what happens if Control-C doesn't work. Well, you can use Control-Z and a Control, which one is it? The right square bracket. Okay. You can also log in again from another window and kill your SSH session from another SSH session. Okay. So there's a lot of different things you can use the kill command for that. So I showed you top, and so one of the things you're asked to do is, what is the load average on your machine? So you would go and grab this information here. It would ask you about what processes does it report, okay? So you would take a screenshot of what you have here, and it asks you how many are running versus sleeping. So you would capture which ones are running, which ones are sleeping. It's asking you which has the highest CPU. So you would look and see which one has the highest CPU and take a screenshot of that. You would also need to see, is it consistent or does it change? And tell me why you think it might be changing as time progresses. And remember, there's not a right answer. I just want to see how you're thinking about this. Okay? Now, use the letter Q to exit top. So you start it with top, and then when you're ready to leave, you just hit Q, okay, and it exits out of it. Now you can chain commands together to understand about processes. So PS minus EF by itself tells us all the processes running on this machine. If I do this and say, I only then see processes that are running that have my name associated with them. So in this case, it's the log file. In this case, I logged in. Okay, in this case, I ran the grep command. So one of the things you're asked to do is PS minus EF and grep for bash. And that should show you any processes that are running bash. Okay. And then you can also exclude processes. So that shows you all the processes except for the bash processes. The next thing is looking at the files of root. Okay, and root, remember, is this drive. I'm outputting all of those to temp. And I'm going to call it ls.log. Okay. And so now, if I look at ls.log, I can see a list of all the files by directory. And I can also count. WC stands for word count. And -L tells it how many lines. And I want, oops, I don't want to pipe. I want to take input. So now if I reverse the direction of that greater than less than symbol, I'm taking input from the right. So I'm going to say count the number of lines in the temp ls.log file. And there are 25 lines in that file. Okay. Now, I think step 5, part 5 was where a lot of people had problems. Okay. So this is going to require that I actually log into my server here. Okay. I'm running Ubuntu. So I'm going to be able to show you the Debian instructions. Okay. If you're running Amazon Linux or you're running Red Hat or Fedora or Oracle Linux or IBM Linux, you are running Red Hat, which means the way you install software is a bit differently. So if you're using CentOS, Fedora, Red Hat, Amazon Linux, IBM Linux, Oracle Linux, that's going to use an RPM format, stands for Red Hat Package Manager. We use packaging software to install software. So on the Mac, you're familiar with an MSI file, an exe file. Sorry, that's Windows, my bad. And on the Mac, you're familiar with a DMG file. Okay. This is how Linux systems do package management. Red Hat uses RPM and a program called Yum. Debian is the other flavor, which is Ubuntu and Debian are basically the two choices there. They use the apt package management system, or the Debian package management system. Okay. So with Red Hat, we're going to use the Yum command to upgrade our system and install packages of software. With Ubuntu or Debian, we're going to use the apt command. Okay. So since Ubuntu is Debian-based, I'm going to go ahead and run the first command here under the Debian section, which is sudo apt-get upgrade. Okay. And this is going to upgrade my host, and it's going to tell me there are some updated packages here, and do I want to install them? Okay. And it tells me I'm going to need to download 7 megs of files, and it's going to use, it's actually going to free up some disk space. Okay? And I can continue with a Y or do N for not continue. If I do Y, it's going to go out and it's going to download from the internet, just like Windows Update. This is effectively Windows Update for your Linux machine. Okay? When it's all done, it will have upgraded all specific packages that it needed to install. The next thing we do is we're going to install package. Oh, hold on, I forgot the sudo command. Let me explain that. The sudo command is a way to temporarily run a command as a privileged user. Okay? We don't want to sudo su to root, which is switch user, because that's very dangerous. We only want to run sudo on a specific command so we don't accidentally do something dangerous because we forget we're logged in as root. Okay? Now, you can ignore my warning about logging in as root, but I guarantee you that if you are going to do that, you're eventually going to delete something that you didn't mean to delete. And then you're going to come to me and ask me, Professor, what do I do? And I'm going to tell you, you have to start all over at the beginning of the course by building your VM again and setting up everything that you set up on it thus far. Okay? So you don't want to just go out and connect to root just because it's easier and it saves you a couple of keystrokes. You want to use the sudo command with a specific another command, okay, individually. So I just use sudo apt-get upgrade on Ubuntu. If you're on Red Hat, you're going to use sudo yum upgrade to upgrade your machine. Now I want to install a web server, and Nginx is a web server. So the example I have here is to go ahead and do some updates on your machine here. So first of all, we're going to do sudo apt-get update. And what this does, this is for Debian, by the way, and Ubuntu. Red Hat is going to do sudo yum install, and then a command, and then you're going to do sudo yum update, sudo yum install, a command, and then sudo nginx to verify. The instructions are in the document. For Debian, what we're going to do, or Ubuntu, we're going to run a sudo apt-get update. And this is just going to make sure my computer has the local copy of all the updates. Now I'm going to do sudo apt-get install nginx. And now it's going to ask me, do I want to install nginx? It's going to install a bunch of packages. And I'm going to say yes. If I say no, I exit and I don't do anything. Okay? A question came up about that earlier. But I want to go ahead and install it. Okay? So now I'm installing Nginx on my server here. Now that it's done, I can do sudo nginx -v, and I can see that it's on my machine here. Okay? The last thing we're going to install as part of this particular homework is something called GNU Screen. Okay? And Screen is a tool that I'm going to show you. I'm also going to show you another tool that I just learned about today that's similar to Screen. But what Screen allows us to do is start something, leave it running, and disconnect from our SSH session, and it's still running in the background, even though we aren't connected to our server anymore. Okay? So let's say I want to start something, and it's going to be a long-running job. Say I write a shell script, and it's going to take 2 hours to run. But I don't want to leave my SSH connection connected the whole time. I can use Screen. So Screen is just this command here. I don't have it installed, but if I follow my own instructions here, okay, I can install Screen. And now I have Screen, and so Screen allows me to set up a profile where I can run multiple commands here. Okay, and I can leave them running in the background. Okay? So I've got a Screen session here, and I could run a command, leave it in the background, come back later, and reconnect to Screen. So think of it like a way to, if you've ever used remote desktop, disconnect from your workstation, leave everything running, come back later from another machine, and connect to it. Another example would be the lab computers, how you can walk away, come back to the lab computer later in the class, and everything's still running, even though you got logged out. Okay. All right, that's it for homework 2. Now, I believe that I've covered all the questions about homework 2, but are there any others? How do we, so you log into your server to install the packages using SSH. So for AWS, you're going to just keep connecting to your virtual machine you connected to. You can always go back out to AWS, click on the machine, say connect, and it will tell you what command to run for SSH. Okay. If you have Windows, I strongly recommend, if you're having problems with PuTTY, that you don't use PuTTY, use the built-in SSH that comes with Windows. I have shown others how to get your SSH key. Okay, so ask in the Microsoft Teams, someone can show you how to get your SSH key if you haven't watched the video, okay? So you can use that to get your SSH key over to your machine, over to the Cougar Courses environment. No, GCP is a little different. So AWS, you have to use the software either that's installed on your Windows machine, the terminal that's on your Mac, or you have to log into Cougar Courses and use the SSH command that's on there as well, okay? Sorry, Cougar Apps, my bad. GCP, you just click the button to open in a shell in a web browser window. You don't have to install anything. Some of you know how to do the GCP keys. Okay? So if you know how to do the GCP keys, or you know someone who does, you can just ask them to help you with that. Okay? And Arseny did a video last semester on how to do the GCP on Mac. And who knows, he might still have that video available. I think it was up on YouTube. Right? But for GCP, you're just going to click on Connect, open it in the browser window, and it automatically will connect for you. Okay. Are there any other questions? Yeah, I would not. Yeah, use the one that's in PowerShell. Don't use PuTTY if you can avoid it. It's been problematic for folks. The key has to be converted. That's complex, and then it doesn't always work. So the main thing is create a .ssh directory in your home directory, okay, if it doesn't already exist. Copy the key file that you downloaded over to that directory. And then all that you need to do is run the SSH command from AWS. And if it can't find your key in your home directory under the SSH directory, then just specify the full path to your key. Are there any other questions? All right, I will post this video. It will probably process tonight. I might even see it later tonight. So as soon as it's available, I will go ahead and post it in YouTube for you. All right, we'll see you all on Wednesday.